Hello all, my name is Amlan Samanta. Welcome to Advanced ML Tutorials. In this class, I will discuss on autoencoder concepts. If you require revision of neural networks and different machine learning techniques, don't worry, I will upload some videos on these topics in a couple of days. Okay, let's start the discussion of the autoencoder. So the agenda of this class is the architecture of this particular neural network, then how it works, and what are the real world applications of autoencoder. So you can see the architecture that I have drawn in this whiteboard. Here, this is the input layer, this is the hidden layer, and this is the output layer. Now let me talk about the main thing about autoencoder. In autoencoder, the number of nodes in the input layer and the number of nodes in the output layer are equal. See, you can see in the diagram that here 1, 2, 3, 4, 5, 6 nodes, and in the output layer 1, 2, 3, 4, 5, 6. So input layer nodes and output layer nodes, same, right? So this is the main thing of autoencoder neural network architecture. And here the hidden layer is consisting of 3 nodes, 3 neurons. Okay. Now, this is the basic simple autoencoder architecture. Okay. Now you can just improve the architecture by adding more input layers, by adding more output layers. But I will not discuss that architectures. This class is very basic, simple understanding of autoencoder, how it works, how the architecture is actually useful in the basic applications of autoencoder. So that concepts I will discuss. I will try to understand with all of you the basic things of autoencoder. So how it works? To understand the working of this particular neural network, you have to first check the basic architecture, the basic schema of this network. This network is divided into 3 components. One is encoder, then the decoder, and in the middle there is a code. Okay, now you can ask me, what is the encoder, what is the role of encoder, what is the role of decoder, and what is the role of code. So let me come back to you step by step. Encoder is doing some encoding operation, decoder is doing some decoding operation, and the code is responsible for representing some representation. Let me explain it in detail so that you can understand the concepts very clearly, and you will be able to explain these concepts in your interviews also. So suppose there is a high dimensional data, and also one thing I should mention that autoencoder is based on the unsupervised learning principle. So you are not providing any supervised label data set, you are not giving any training data, you are just providing some data, some examples without some labels, right? So I am explaining you how this architecture is actually working in a problem statement, right? So suppose there is a high dimensional input data coming from the outside world. Okay, so what this encoder block, which is dotted, right? See here I have dotted, right? In this block the input layer is placed. So the outside world data is inputted in this layer. So what this encoder block is doing here? We have to understand this. Encoder is actually converting this high dimensional data into some representation. I am mentioning one term here for your vocabulary. This is called latent space representation. Latent space representation. So this encoder is actually transforming your outside data or the input data into latent space representation. Okay. Now you can ask me, what is latent space representation? Latent space representation is nothing but the compressed version of your input data in a lower dimension. So compressed version of your input data in a lower dimension. So suppose your data is 6 dimensional, and for example, suppose it is converted into 3 dimensional. So this encoder block is doing that job. Now let me come to the point of code. So this component is actually representing this latent space representation. So first data is coming in this layer, then it is converted to code. So code is actually representing this latent space representation. Now you can ask me that this is actually converted into some lower dimensional data and code is representing that. What will be the next step? So the next step will be the decoder portion is coming in the picture, right? So here, see in this picture, I understand that you are not able to clarify from this figure because this is little clumsy, right? But still I am trying to help you. See here, the dotted line is the decoder block. Now decoder block is actually the third and final step of this working of autoencoder. It is taking the input as this latent space representation. So this latent space representation is going in the decoder block, the output layer. Now what is the job of the output layer? It is actually reconstructing. It is reconstructing. I am writing this phrase here. I am removing this text. So decoder, right? Decoder is reconstructing the latent space representation into the original input. What is the meaning of this line? Reconstructing the latent space representation into the original input, or you can say that reconstructing the original input back from the latent space representation. So basically what it is doing, finally this autoencoder architecture is actually reconstructing the input as output by doing a compression or by doing a latent space representation of your input data. So this is the major working process of autoencoder, how it works, how it actually processes the data, and how it actually generates its output. Now coming to one important thing, that how it actually converts the input into latent space representation. Let me do one thing. I am just removing all these things. So how is latent space representation? This is the major crux of autoencoder. Why I am saying the major crux of autoencoder? Because the scientists or the researchers who actually designed or who actually invented the architecture of autoencoder, they actually designed this autoencoder in a such manner that this network can learn some important properties of data by doing some dimensionality reduction. So the researchers actually designed this network in such a manner that it can learn some important properties of the data by doing some dimensionality reduction. By doing some dimensionality reduction means it is actually reducing the original input's dimension, and then it is reconstructing from the lower dimensional data to its original data, right? So this is the major crux of the autoencoder architecture. Here actually the latent space representation is actually done or implemented by some unsupervised ML algorithmic technique. Okay, the latent space representation is actually implemented by some unsupervised machine learning algorithmic technique. You can consider, for example, principal component analysis, right? Principal component analysis, PCA, right? So PCA is actually a algorithmic technique by which you can actually reduce the dimension, and if you utilize that, or if you can leverage that algorithm in the autoencoder architecture, then you can achieve the same result, right? Because this is actually reducing the dimension, and also autoencoder is also reducing its dimension and converting it into latent space representation. So this is one major aspect, right? And the final aspect that I want to highlight here, that what are the real applications of autoencoder. Okay, so see, every neural network architecture have some real world application. We have to know the real world applications, because otherwise we will not be able to understand or decide which algorithm to choose for particular problem statement, right? So there are lots of there are many applications of autoencoder architecture. First application I would mention that denoising of image. This is a very important application of autoencoder. What is denoising? Suppose you have a family photo in your house, and that family photo was captured way long back ago, actually maybe 50 years ago. Okay, maybe you were not born in that time, but you have that collection in your album, right? So in that photo, suppose you want to improve the quality of the photo. The picture quality is very lower quality picture, okay, and you want to improve the quality. So here in this particular problem statement, you can apply autoencoder. Okay, another application I am mentioning. Suppose there is a album in your house, and you have one black and white photo. Okay, black and white photo. Now nowadays black and white photo is very much low use, right? You are mostly capturing color photo, but you want to convert it into colored photo. So here also you can use the autoencoder. Autoencoder can actually convert this black and white into your desired colored photo. So these are two very important applications you can definitely mention in your interviews if somebody asks what are the applications of autoencoder. So that is all about this class. In short, I discussed the architecture of autoencoder, how this autoencoder works in a very basic or very easiest possible manner, and what are the some major applications of autoencoder in real world use cases. If you really like this content, really like this teaching and find it useful, please like this content, like this video and share it with your friends. And in my next video I will discuss about different important questions that are normally asked in some machine learning positions or data science position interviews, and in those interviews how you can confidently reply to that questions with some concepts and efficiently manage those questions. I will discuss about those interview questions. And yeah, if you have any queries, definitely you can reach out to me by posting some comments in this video. And yeah, so that's all about. Till then, goodbye.